Okay, so this is going to be how to solve exponential equations. And we have already talked about how to solve logarithmic equations. It's very similar when we're solving exponential equations since logs and inverses are inverses, or logs and exponents are inverses of each other. So logs, exponents are inverses of each other. So in order to solve these types of equations, we're going to need to use the inverses so that we can get the x out of the exponent or the x out of the log. So today we're focusing on getting the x out of the exponent, which is going to be using logs to get that inverse. So our steps are going to be very similar to what we had for solving logarithmic equations. The first step is going to get the exponent by itself. So like for example, if I had 3 times 2 to the x plus 1 is equal to 5. I want to get rid of this plus 1. I want to get rid of this 3 so that I just have 2 to the x equals some number. So we're basically solving for whatever that exponent is. And then we're going to rewrite as a log, and this is going to be using first, last equals middle. So when we were solving logs, we rewrote as an exponent because the exponent was the inverse. Now when we rewrite as a log, the inverse of exponents is logs. So that's why we need to rewrite it as a log so that we can get that exponent out of the x out of the exponent. So rewrite as a log using first, last equals middle. Solve whatever equation is left, and this is you're gonna have like log of 2 of 7 is equal to, I don't know, 5x minus 1. And this log of 2 of 7, log of base 2 of 7, you're going to plug into your calculator. It's going to be some weird decimal, and you'll either use change of base formula. So change of base says I do log of 7 divided by log of 2, or you'll use that math button on your calculator that will change the base for you. So math, go to log base and change it for you. If you don't have that change of base in your graphing calculator, you'll have to use change of base. So just kind of some reminders, log of base b of a is going to be equal to log of a, so the number inside the log, divided by log of b, the log of the base. So if you have the change of base in your calculator, plug it in with the math button. If you don't, remember this change of base formula right here. Okay, then last step, same as before, check your solution, make sure that it actually works when we plug it back in to our original equation. So very, very similar steps. Get the exponent by itself, rewrite it as a log, solve the equation using change of base or math, and then from there, like this, log of base 2 of 7 equals 5x minus 1. I'd figure out what log of base 2 of 7 is. It's a weird decimal. I'd add 1 to it, divide by 5. I'd still get a weird decimal. So these are all going to be not super nice numbers, whereas when you were solving logs, you had some kind of nice numbers. So these are all going to be kind of weird, funky decimals. Okay, so there is our steps. So let's look at some examples. We got log of, 3 to the 2x equals 81. So this one, I don't have anything in front of the exponent or out to the side of the exponent that I'm multiplying by the exponent or that I'm adding or subtracting to the exponent. So for step number 1, I'm done. The exponent's by itself. So I can move on to step number 2, which says to rewrite it as a log. So I'll write it as log of base 3, since that's the first thing that I see, of 81 is equal to 2x. So So first, last equals middle. In my calculator, do log of base 3 of 81, or do log of, so this is to my solving step, log of 81 divided by log of 3 is equal to 2x. So when I do that, either the change of base or the change of base formula, I get 4. So 4 equals 2x. Then divide that guy by 2, divide that guy by 2, we get x equals 2 for my solution. So when I plug it back in, for my checking part, if I do 3 to the 2 times 2 is going to be 81. Get 3 to the 4th equals 81. And 3 to the 4th does equal 81. So we are good with x equals 2. That's not a extraneous solution. Okay, next one. 2 to the x equals 5. So again, step number 1, done. I don't have anything in front of the exponent. I don't have anything to the side of the exponent that I'm adding or subtracting to that 2 to the x. So exponents by itself. Second step, rewrite it as a log using phlegm. So log of base 2, first, last, equals middle thing that I see. Okay, this one's not going to be super hard to solve because I don't have anything with my x, like I don't have 2x minus 1 or even a 2x. So I'm just going to figure out what log of base 2 of 5 is equal to in my calculator to solve by either doing log of 5 divided by log of 2 or changing that base in my graphing calculator. So if I do log of 5 divided by log of 2, that's going to be 2.39, and that goes on forever. So in order to check this one, if I do 2 to the second answer, I should get 5. So if I do 2 to the 2.319, and if I do 2 to the second answer is in that negative button right next to enter, I should get 5. And if I do that, that's how I'm going to check to see if my answer actually works. So it's not as important on the law or on these exponents to actually check because you don't usually get extraneous solutions because we don't have like as many rules for exponents because I can plug in negatives into exponents, whereas I can't plug in negatives into logs. So there are actually no restrictions on logs or on solving exponents, whereas there are for solving logs. So it's not super important to actually check on these ones because they will 99.9999% of the time work. Okay, these ones are a little bit harder. Okay, so I have to delete everything first. Solid. We got 9 to the 2x plus 1 plus 2 equals 3, and then 4 to the 2n minus 1 minus 4 equals 64. So this one does have some stuff outside of the exponent. Number 3 has a plus 2, and number 4 has a minus 4. So for my first step, technical difficulties. So for my first step, I will want to get that exponent by itself, so I'm going to subtract 2 from both sides. And then we'll have 9 to the 2x minus 1 equals 1. Then when I rewrite, I'm going to have log of base 9 of 1 equals 2x minus 1. In my calculator, if I do log of base 9 of 1, either using change of base or math button, you get 0. So log of base 9 of 1 is 0 equals 2x minus 1. Now onto the solving step. So third step, get x by itself, add 1, get 2x equals 1, divide by 2, get x equals 1/2. Okay, go back and check. If I do 2x minus 1, or 2 times 1/2 is 1. So 1 minus 1 is 0. 9 to the 0 is 1. 1 plus 2 is 3. So that actually works for when I check it. So try number 4 on your own piece of paper, and then come back in a few seconds. So pause the video, come back after you solve number 4, and see if you got the right answer for number 4. So come back, pause it. Okay, here's the process for number 4. So all of this right now, once I get this log of 68 divided by log of 4, that's going to be a decimal. I can just add 1 to that, and it'll say like answer plus 1. And this is going to give you the most exact answer. So if I do it as a decimal approximation, like right here on the screen, I have 3.0437. That's not going to be as exact as if I just do it in my calculator, add 1, divide by 2. So if I add 1, I get 4.04373, goes on forever. Divide that guy by 2, got 2.0218657, and again, that's not all of the decimal places. So we're going to write this as n is approximately, so that little equals sign, but kind of wavy equals sign, is approximately 2.021, and it looks like 9 if I round it to 4 decimal places. So again, that's not the exact answer, but it's an approximation. It's a pretty good approximation because 4 decimal places is pretty good, but that does go on forever. So hopefully you got 2.0219. Okay, the E ones. These are going to be a little bit different because they have an E. So one thing that we need to remember, if I have the log of base E of something, x whatever, then that really equals natural log of x. So when I rewrite it and I have a log of base E, I just need to remember to plug that in as natural log of x instead of log of base E. You'll have to do a whole bunch of extra buttons if you plug in log of base E. So just remember, if you have an E as your base of an exponent, then you'll have natural log when you're going to rewrite it as a log. So first step, we've got 4 times e to the x minus 3 plus 1 equals 12 for number 7. So we want to get that exponent by itself. So we're going to get the e by itself. So we'll subtract 1, get 4 times e to the x minus 3 equals 11. Divide by 4, divide by 4. So we'll get the exponent by itself is e to the x minus 3. Shoot. Technical difficulties again. Okay, so our second step, we had e to the x minus 3 equals 11 fourths. And we'll leave it as 11 fourths because that's going to give us our most exact answer. So then when we rewrite it for the second step, we'll have log of base e of 11 fourths equals x minus 3. Now I need to know, though, that log of base e is really natural log of 11 fourths equals x minus 3. So in my calculator, I'll plug in natural log, which everybody has, so you don't even need to change the base. Natural log right under log of 11 divided by 4, which again, going to be a weird decimal. You get 1.116092. Add 3 to that. So then for the solving part, gonna take natural log of 11 over 4 plus 3 to get x. X is gonna be approximately 4.011. Okay, try number 8 on your own. Pause it, see if you do the same thing, come back after you've solved it out, and then you'll be all set. Okay, so I'm just gonna write it down. So step number 1, get that exponent of e by itself. Subtract 2, divide by negative, get e to the negative x plus 5 equals negative 5. Rewrite. When I rewrite, I should have natural log of negative 5. Oh, this should be positive 5 because it's a negative e. Sorry. Natural log of positive 5 equals negative x plus 5. Natural log of positive 5 is a weird decimal. Subtract 5 from it. Divide by a negative. Hopefully you got x is approximately 3.3906 if we're rounding. Okay, so exponents very similar to solving logs, same kind of steps other than when we rewrite, we're going to rewrite as a log since the inverse of exponents is logs. So that is it for today. Quiz on Friday over solving logs and exponents. We will also be reviewing before, but if you missed today, please watch this video or hopefully watch this video to kind of understand what we did in class today. There is also a logs or exponential worksheet on the website that you'll need to get. It's not going to be officially due, but it's just for you for practice before the quiz. So I will not be collecting it, but it is for you if you need more practice for the quiz.